Here is my work on the Drawing Quantities Practice worksheet. You could draw them differently. The point is that you want to look for the item and its quantity, and you want to label things to show that what the difference is between those different items and those different quantities, and also to show the structure of the problem. So number one, there are 5 boys and 3 girls that were rescued, and I would simply do it just like this. I would say, here are 5 boys, and here are 3 girls, and I have drawn them, and I have labeled them. And if you wanted to make them more decorative, that's okay, but there's really no point in doing a lot of effort. You're just trying to show the structure, not making them decorative. For number 2, he washed 8 small plates and 4 large plates. So 1, 2, 3, 4, 5, 6, 7, 8 small plates. 1, 2, 3, 4 large plates. Sometimes people wonder if the large plates should be drawn large and the small plates should be drawn small. Should they be? I don't think it's a requirement. Could they be? I don't think there's anything wrong with that. The whole point is to show the quantity in the structure, and so drawing the 4 large plates just as larger plates would certainly not be a bad thing. It certainly might visually give us a bigger or a different view of the situation to remind you of large versus small plates. So either way is fine with that. For number 3, 3 eggs for pancakes and 7 eggs for French toast. So here are 3 eggs for pancakes, and here are 7 eggs for French toast. Now what's crucial in this problem is paying attention to how you label them. If you just call them eggs, then we're not really seeing a difference in the quantities. We have 3 eggs, we have 7 eggs. If you just called them pancakes, French toast, then somebody looking at the problem or the drawing might think, oh, those circles are representing pancakes and those circles are representing French toast. So your labeling is more important here. And so you say eggs for pancakes and eggs for French toast. So there are times when you don't want to be stingy with your labels because you need to be clear that they are eggs for 2 different situations and what those situations are. For number 4, 3 groups of caterpillars. In one group there were 4 caterpillars that turned into butterflies. In another group, 12 turned into butterflies. And the third group, 5 turned into butterflies. So I've got my circles representing my caterpillars that turned into butterflies. What's important here is to show the different groups. So group 1, group 2, group 3, and you could say group 1 butterflies, group 2 butterflies, group 3 butterflies. I think it's pretty easy to tell that they are butterflies from the word problem, although if you're concerned, you might label them butterflies so that nobody confuses them with caterpillars. A question that comes up on this problem sometimes is it important to know how many caterpillars were originally in each group? In other words, do we need to know how many caterpillars didn't turn into butterflies? Well, with the information that's given, and not having a question being asked based on this information, we don't know if that's important or not. But they didn't give us the information, so it's probably not important. What's important are the number of caterpillars that turned into butterflies in each group. When we look at problem number 5, we see that she practiced the song 14 times. She practiced the song 8 times on her own. So let's say I do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. She practiced the song 14 times on her own. So this is times practiced on her own. Okay, and then, no, I'm sorry, times that she practiced. Okay, just times that she practiced. And then times that she practiced on her own, I would do like this, give them a special designation. So on her own, I would write out times practiced on her own. But what's important to show here is that she practiced 14 times, and of the 14, 8 of them she practiced on her own. And the common response would be to draw the 14 times she practiced and then 8 more times that she practiced on her own. But the wording doesn't say that those are 2 separate practices. They're saying out of the 14, the 8 she did on her own. So you have to show that the 8 are part of the 14. If you drew them separately, it would look like she practiced 14 plus 8 times total, and she really practiced 14 times total, out of which 8 she did on her own. For number 6, there are 7 containers of mint ice cream. So this is mint ice cream, and there was the same number of chocolate ice cream. And so they didn't tell us explicitly that there were 7 chocolate ice creams, but they implied it because they said there was the same number as mint. And if they didn't happen to tell us how many mint ice creams were there, we could have still drawn the relationship. We could have just said something like this many mint and that many chocolate. And using a line instead of individual ones is telling us that the quantities are still the same, but we're not deciding how many quantities are there. And this is something that comes up often. If they had said the same number of mint as chocolate, we don't want to decide that number by using the individual circles. We want to show that they're equal by using line segments, or using one line segment and saying mint here and chocolate there. And the point is that you don't make up numbers for the problem. If they don't give you the numbers, you can't make them up and just decide that's what they are. And if they didn't give us the numbers for the mint and the chocolate, and they just told us there was the same amount, we could still represent it with our lines. With number 7, he saw 10 toy trucks. So we draw the 10 trucks. 6 of them have ladders, so we could mark the 6 with the ladders. So this would be trucks. All of them are the toy fire trucks, and then trucks with ladders. Although I'm not sure I would draw that separately. I think I would say truck with ladder. If I drew it separately, my concern is that someone would see that separate thing and not recognize it's like a key to how to read it. So if I do it this way, I can show that I have my truck with a ladder as the same part of the trucks. Another way you could do it, and I'm kind of compacting them here in the space that I have, but let's say he found 5 trucks. You could say, here are the trucks, and let's say he had 2 with ladders, then we could say with ladders, trucks with ladders here. And so that way you're showing again that all 5 of them are trucks and 2 of them are the ones that have the ladders, and you indicated those with putting a mark on the inside. Number 8, Josh has fewer dogs than Mikey has. Mikey has 2 dogs. That's an interesting one because these are Mikey's dogs, and it says that Josh has fewer dogs than Mikey. So we don't really know if Josh has 1 dog or if Josh doesn't have any dogs. And the wording of the question is ambiguous here. We're not sure of it. So that's one of those things that you would, if you were reading the whole word problem and there was something to do, something to calculate, you would be looking for some sort of wording that would tell you that he for sure had a dog. For number 9, we say Shane's board is 7 inches tall. So this is 7 inches, and this is Shane's board. And it says Tim's board is 3 inches taller than Shane's. So we draw this, and we want to show that relationship. So this is Tim's board. And we know that it's taller than Shane's. We know that this distance is 3 inches. And we know to go up by 3 inches instead of down 3 inches because of the wording that says Tim's board is 3 inches taller than Shane's. So we know to go Shane's height and then 3 inches above that. Number 10. Now, Selma spends 2 quarters on a glue stick. Brent buys a highlighter for 3 dimes. Without the question or more information given in the problem, we can't be certain if the quarters and the dimes are the important quantities, or the glue stick and the highlighter are important quantities. We're not sure about this. We don't know if we're supposed to draw the glue stick or the highlighter. So if we need to draw something, we can say, here are the quarters, and here are the dimes. We could draw it like this, or we could do something like, I don't know, like 1/4. This one's a challenging one, because if we say 1/4, 1/4, and this is the same as 1 glue stick, and then we could say, okay, here is 1 dime, 1 dime, 1 dime, and here is 1 highlighter. And so we're trying to show that relationship between 2 quarters and the glue stick, 3 dimes, and a highlighter. So as I'm saying, without more information, especially without the question, we don't know which quantities are the important ones that we want to emphasize in our drawing. And that's really important to keep in mind, because a lot of times when I've given this problem to people, I'll say 2 quarters for the glue stick, 3 dimes for the highlighter, and someone will be like, 80 cents. Well, why did you say 80 cents? Oh, because 2 quarters and 3 dimes adds up to 80 cents. But that might not be the question. You're trying to answer the question by doing the calculation you're guessing that might happen. And that's not the point. If you don't know the question, any calculation you do is not worthwhile because you don't know what calculation you need to do in order to answer the question. Number 11 is interesting because it tends to throw people off. It says he made the lasagna, he put it into the oven at 4:30, and he took it out 1 hour later. And what typically people want to do with this is draw a clock and say 12, 3, 6, 9, okay, here's 4, here's 5, and they want to say, okay, here's 4 and 30, and then they want to do some sort of drawing to show how it went to 5:30 afterwards. And the problem with this is that we don't know, we're not given the information that it ends at 5:30. You're calculating to get to the time at 5:30, but we're not asked to calculate anything. We're asked to draw the quantities as they were given. And so trying to put it onto a clock face, I've had people draw the clock face, you know, here's my 4:30, and then they draw this line all the way around and they say 1 hour. And the problem with that is, okay, you're indicating that the longhand goes around 1 hour, but did you go 1 hour to get to 4:30, or do you go to start at 4:30 and go 1 hour after that? The picture here isn't clear, but people really, really want to draw clocks because a time was given. And what I would do for this problem is I would not be so fancy as to put in a clock. And I would say, look, here is 4:30. This is where he starts. He puts the lasagna in the oven. This is where he ends. And here, 1 hour passes. So you're showing the structure. You start at 4:30 and it goes for an hour. But we're not calculating the 5:30. We don't need a clock face to try to make a clear picture on. I think this structure really shows what's going on. We start at 4:30, we go for an hour. If they ask us what time did he take it out, we can easily calculate it out to 5:30. On number 12, I look at the quantities before I start drawing. And I see 6, which is fine, and 4, which is fine, and then 73, which makes me say, ew, I don't want to draw 73 individual pieces of candy. That is just way too much drawing that I want to do. So I ask myself, what can I do in order to show the relationships between the quantities and not have to draw out 73 individual coconut candies? So what I decide is, I'm going to draw these lines, and I'm going to say 6, there's lime, and 4, there's orange, and then I'm going to draw a long one, and I'm going to say 73, that's coconut. And the parts that I need to emphasize to you is we don't have to draw these guys so that they are correctly in relationship to each other. In other words, this is 6, this is 73, that's more than 11 times the quantity of 6, but we don't have to draw it in proportion. We can just say 73 is a bigger quantity than 6, just like 6 is a bigger quantity than 4, and we're showing the relationship between 4 and 6 and 73, and we don't have to draw them to scale. And this is one of those times when, like I said, I didn't want to draw 73 individual coconut candies. So even though these are counts, I'm still using a line, or in this case, a strip, to show the quantities so that I can still show the relationship. I can still compare the quantities. I am prepared to answer whatever question they might ask about these quantities. For number 13, it says they walked 2 blocks from the park to the store. So here's the park and here's the store, and I would say 2 blocks, that distance. And then they walked home. So here's walking to home. And we don't know how many blocks that is, but they're telling us that the total distance they walked was 5 blocks. Okay, they didn't ask us what this distance is. We don't know what the question is going to be. But we can show the structure by saying park to store, 2 blocks, store to home. We don't know. Total distance traveled, 5 blocks. We're all set up with the structure and it looks good. And a question I need to ask you is, what if the route that he took when he walked, what if it wasn't straight? What if it wasn't exactly straight 2 blocks to the store and then straight from there 2 blocks to the house? What if he walked something like that? Does that matter? And unless the question gives us more information, or the problem gives us more information, or the question brings up something about it, then no, it doesn't matter. Because what we're doing is just talking distances. We don't know if he walked directly from the park to the store, if he wandered around a little bit, but he walked 2 whole blocks. That's all we need to know, and drawing them as straight lines and drawing the whole route that he's taking as a straight line is not a problem. On number 14, you've done this a million times, but this problem is in there for a reason. It says that all the sides are 7 feet long. And it's generally helpful if they're put in the wording saying all the sides are 7 feet long. It's generally a good idea to label all the sides as 7 feet long, just because you don't know what the question is. If you knew what the question was, or if you had other information, you might not need to label them all. But right now they just say they're all 7 feet long. And you might, well, and they say it's a square too, so that helps. That's a little bit extra information. So maybe you don't always have to label them at 7 feet, but if they just said a sandbox with the sides 7 feet long, label them all. The fact that they say it's a square sandbox, you might not have to label them all. Now, the next thing I want to ask you about this problem is, how accurate does your drawing have to be? Do you have to draw it so all the sides look like they're 7 feet, or at least look like they're all the same length? And the answer is no. If you label them, then the label overrides the length. I could draw something like this and say, look, all these sides are 7 feet long. And you have to work with that and say, look, they're all 7 feet long, even if it doesn't look like they're all 7 feet long. So we don't have to draw things to scale. We use the words and the quantities that are given in the problem to help us understand what it should look like. And if we don't happen to draw it to scale, that's okay. For number 15, 2 cups, you could draw 2 cups like this, stacked. 3 cups, you could draw like this, stacked. But once we start getting to 6 and 11, I might not want to draw out all 11 of them. It's a little hard to see, to draw all of those guys and make it look right. So here's where I would tend to draw them as strips, not worrying about drawing them to scale, but showing the relationship of 11 is bigger than 6 is bigger than 3 is bigger than 2. They don't have to be drawn to scale. They don't have to be showing each individual cup. You do want to associate the numbers with the strips so that anybody looking at them can recognize what's going on. When you work these problems, on your own. So assuming that you've already tried this and now you're looking at my results to see how you did compared to what I would do, go back over and look at your work and say, are my drawings showing the structure? Are my drawings helpful in showing the calculations? Showing how you might calculate something no matter what the question might be. You might change the drawings later on after hearing what a question might be. For example, for this problem, if the question turned out to be, how many cups did he stack total, or did he have to stack? I might then redraw this and say, all right, here's 11, here's 6, here's 3, here's 2, and this is the total number of cups that he had to draw. So my drawing would change depending on what the question could be. If they say stack 3 had how many cups that was fewer than stack 4, then I might leave this drawing, but I would add this, and I'd say, okay, here's the difference between them. Or if they said, if I put the first 2 stacks together and compared them to the third stack, then are they more or less? Then I would redraw it like this, and I would say, okay, now I'm going to compare the height of this stack to that stack. So yes, your drawing can change depending on what the question is. Draw what's there, draw the relationships and the structure of the problem as it's given to you. And then if you're given a question or more information, then you can change your drawing to suit it. And that's something I've always tried to emphasize when I've taught any student, either in this class or in other classes. When I've taught them about word problems, I try to teach them to read the problem all the way through first and try to get a mental image of what's going on. Start trying to imagine what's happening with the quantities and how you would stack them or draw them or show that relationship. Imagine it before you draw it so that you have the one drawing that is useful to the problem once you're done drawing it. So go back over your work, think about what you've done, see if you can improve your drawings at all.